Let me start the recording so we can have it on record. How was the exam?
The exam was good.
Good, right? No?
Not good.
Why? It was the rigid body kinematics.
Yes, in the second question, I missed the angle, which was theta.
What did you do then?
I couldn't solve the second question.
Nee, you said I couldn't see the angle. So what angle did you take?
He didn't took the angle and did not resolve the V that was acting in this direction. So he couldn't.
VB equals to VA.
Huh?
VB equals to VA plus omega AB plus RA with respect to V. I knew RAB, I knew VA. One unknown was omega AB, and one unknown was VB.
Oh, so you did not resolve it because I think that one was at an angle.
We were to make components.
You just took it as VA and just went for it.
Yes.
I couldn't solve that, so that was the problem.
Sure. It's okay, but there is just one portion that you made mistake now. Okay, so I usually subtract points for wrong steps, but I don't think I have ever just taken out all the points. Okay, I think we are late today.
So when should we expect the marks for the exam?
Oh, no, I don't think that I can. I have to grade in another exam packet, then I will probably by your final exams. Okay, everyone, I'm happy that you're all here today. Let us start. We have started the recording, yes. What was your question? Impulse momentum. So let us quickly go for it. What about Abu? Everyone is fine with the exam, right? Abu? Oh, really? MA, which is equal to d by dt mv. Okay, everyone. Then, okay. Well, we arrive at our today's topic, that is rate of change of linear momentum. How many students have already taken a fluids course? Anyone who wants to raise their hands? No? No one? Fluid mechanics. Okay. Rate of change of linear momentum is force, right? In the fluid mechanics, you will also go over a formula. Anyway, since you haven't taken fluid mechanics, no need to go to that side. Now, define linear momentum. Okay. Okay. Again, this also comes under the heading of kinetics, right? So the definition of linear momentum is G equal to mv. And when I tell you that summation of forces is equal to 0, what I am trying to imply is that d over dt is also 0, right? Of course. No, not constant change. Huh?
Change in G is constant.
Change in G is 0. G dot. Very good. I will answer your question. Look, d over dt, G is not constant. It is 0. You know why?
The initial momentum is equal to final momentum. If d over dt of G is.
That's what I'm saying. But when d over dt, G is a 0, d over dt, G is not constant. That's what I'm saying. When I said d over dt, G, you said constant. I said no, it's not constant. D over dt, G is 0. G is constant with time, if you want to call it, and then this becomes equal to. Summation of forces is equal to G dot, as one of our students told me right now, which is equal to dg over dt. So I will actually write in fancy English that delta G, okay. Delta G is area under the summation FT graph. Okay, in your physics class, did you talk about impulse or not?
Yeah, we do.
You did, right? So integral of T1 to T2 summation F dt is equal to the change in momentum. Of course, right? Huge amount of force, X for a brief time, you get a massive change in momentum. You can have an example of baseball or cricket, right? Massive force in a small time, boom, there goes the ball. So, okay, I think that's enough. If there is something that you want to cram today, is just this little formula, and I will start with the problem. Do you have any questions? Okay, I will open my own picture. Pen. Where is my picture? Okay. Let's do a couple of problems. F into T equal to mv2 minus mv1, but this is the right way.
This is a general question. Is momentum always conserved?
Is momentum always conserved? So for example, when you say momentum always conserved, there is a force that is acting for time. This is equal to the change of momentum. When you say momentum is conserved, that means the change of momentum is zero. So for example,
That's in the
No force is acting.
I will answer his question.
It is in static states, right?
No. His question is something different.
How?
Your question is this. This strikes this ball. Huh? So then they used to tell me M1, V1,
Equals to
mass before it hits. I'm sorry, what was that? M1, the total momentum before the hit is equal to the total momentum after the hit. So the total momentum remains conserved. That is the conservation of momentum kind of a thing. But if force is acting, there's a change in momentum. Okay, I did not cover this topic, by the way, so I'm happy that you brought this up. 654321. I'm waiting for our students to finish them. I think we have less students today because of the Spring Festival, right? No,
Yes.
probably.
Probably.
Ah,
We didn't saw you in the spring.
I was there actually with my daughter. Not late at night because the music decibel levels were too high for a little kid as well as for me actually. It's too loud. But I was there. Why wouldn't I be there?
Do you want?
Absolutely, I loved it.
Did you miss it?
Huh?
Did you miss the festival?
Did I miss or enjoy?
And because the last festival was done in 2019.
Oh no, this is the first time I am in Cyprus, so this is my first festival here.
And when did you start as an instructor?
At O2,
Yes, in which year?
I came to O2 last semester, so just few months back. This
Wow.
really, I came to Cyprus on 27th of September 2021.
21.
Yeah, 27th September 21.
So you're new this year.
Yeah, I'm absolutely new. I think I ended up decreasing the thickness of line. What happened? Oh, come on, how the line thickness changes. Anyone? You know, anyone who knows these things? You see, it decreased.
Maybe white people.
Okay, anyways, I will go with the small thickness. I don't know. Oh, come on. Anyways.
Is there lightweight setting?
I don't know. Spotlight. Line width.
Line weight.
Oh, life is beautiful again. Okay, let's go back. So we have this P bracket T, and then I have mass M, then I have M equal to 10 kilograms. And we have students who are saying, what kind of a question is this? I have this object sliding over it, and this is frictionless. The question says that I have a graph that is shown to me. I will go at supersonic speeds now. This is P bracket N. This is 100 Newton. This is 20 Newton. The question says that for the applied force that is acting in this fashion, where we have the 5 seconds here, where we have 10 seconds here, where we have, let's say, 15 seconds here, and we have time on this axis, and the kind of loading given to us is like this. Boom. Then this is at 20, at 15, somewhat like this. I will try my best to make as appropriate of a diagram as possible, and it goes all the way like this. So this is my 20 Newton. And this is my 100 Newton. And this is my 10 seconds. How many students agree? And this is my 5 seconds. Okay, give me the values: 5 seconds, 10. And this is 15, okay? Okay, the question says, find, this is, by the way, a fresh up question. Our actual question is the next one. It will just find V2 after 10 seconds. Do it and give me V2 15 seconds. If V1 is equal to 0 at t equal to 0 seconds. Okay, do it. Oh. Okay, so I think I can help you a little bit. The first thing I will say is, I will say that, what 50? V2, very nice. Very good. So delta G is M delta V, which is area under PT graph. So delta V is equal to area under PT graph divided by M. In other words, V2 is equal to area under PT graph divided by, how many students agree? M. So I suppose this is how he found. our one of the students in class. So I say V2 equal to area under PT graph. So I think it will be, why don't you all help me with this one? So I suppose 100 multiplied by 10. So that is 1000 divided by 1/2 base into height. So it gives me 1/2 base is 10 into, this is how you did it, right? Base into height plus V1 is 0 and V2 comes out to be 50. So I suppose this is how he found it. Okay. Okay, 5 seconds, 10 seconds. Okay. Now that you have successfully found this, the last piece of the puzzle is giving me V3. Why don't you do V3 as well?
Is 80 fine, not
80? Very nice. Good answer again from our student. So that becomes MV3 minus MV2 is equal to delta G, M delta V, right? So I don't want to confuse you. So V3 minus V2 is equal to area under the graph. That is, you have to give me a little time. I forgot. I think I will have to make a rectangle. Just bear with me, please. I think this is how our students are doing it.
It's trapezoids.
Like this, triangle plus this fellow. And I will say it is V3 is equal to 5 multiplied by 20, that is 100. So it is, okay. And the big triangle is 100 minus 20, 80. 80 multiplied by 5. So it is 80 multiplied by 5 over 2 plus 100, which is equal to, फिर divided by mass. I made a mistake? I probably.
V2 is 500. Because 1000 divided by 2.
V2 is 50, so this will become minus 50.
No, it should be 500.
Minus 5.
50?
500.
Why?
Okay. Yeah.
What happened? V3 minus V2
You took
is,
the math and gave us-
no, mass I have taken them. Now give me, using a calculator, why don't you tell me the answer? I can make a mistake. I did? Okay. I did it very quickly. No, I will answer Abu and your question. The 100 came from 20 multiplied by 5, this rectangle 100, and 80 multiplied 5 divided by 2 came from 100 minus 20 is 80. So height, and this is base is 5, 1/2 base into height. 1/2 5 into 80. And there are students who are saying, but why did you do in little chunks? Can we find V3 directly from starting? Oh, of course. Then you will do this whole thing plus this whole thing plus this whole thing as V3 minus 0 is equal to the area under the whole curve divided by the mass. But anyways, I'm stopping here for 3 minutes. Absorb this and let me know, because next problem would really challenge all of you. So think about it. We have an online student. Oh, we don't have any online student today. Why do we need impulse momentum concept? Because somebody was applying a force, but look at how the person applied the force. The force is a function of time, right? So life is not easy for you. If you just start to play with summation F equal to MA, the problem will become very complicated for you. Okay, I think our students are done. Should I move to the next slide? Okay, take your time then. I will open the next thing on Paint, by the way. It will take a lot of time of me. Should I? Okay. So I will do 6, 5, 4, 3, 2, 1 screen. Let's go for Google. Okay, let's start the problem. This is our today's problem. Okay, let's find the problem. Where is the problem? Where is the problem? Problem. Yeah, this is the problem. The problem says, yeah, this is the problem. Don't look at the answers, please. Take a snapshot.
What is that?
I will tell you. Okay, this will really challenge the imagination.
A big imagination.
Oh, come on, the laptop should not hang because there is no way. This laptop is on ventilator right now. So let me open the Paint. Okay, 6, 5, 4, 3, 2, 1 screen shared. Boom. Huh? Copy. Paint. Okay. Done. Okay, let's now go for the problem. I will just remove the things that we have to write today. So I will save my time. Control X, Control X, Control X, Control X, X. Okay, now solve the problem. The problem says that you have the same object that I showed you last time. This time around, however, this is the mass. Please bear with me. Bear with me, please. Again, we have force that is being applied. What was the force? Like this, right? Probably from this direction. P bracket T. M is equal to 10 kilogram. Yes, no. I gave you the value, right? This again tells me that VI is equal to 0. But this time it tells me it's not frictionless. It gives me the values. Now what I will do is I will try to solve this problem. So this is the actual problem. I know that you are wondering what on earth happened. Did you change the problem? No, I did not change the problem. I will tell you why. This is the actual problem. And please also remove the 39.24 as well. I will explain to you. These are the things that you will identify.
Time axis.
Time axis. Oh, of course. That's my mistake. Okay. Okay. Any questions for me?
What's the time?
What's the time?
Time.
For every intersection.
Acha, acha. Okay, okay. Yeah. So it is 100 here. So the question says there is a 10 here. Then the 20 line is this line, the purple. If the 20 is the purple line, this is 2 seconds. Did I answer your question? Okay. The purple line is 20.
T is after time.
Huh?
T.
T is time.
No, after time. What is that?
You mean this one?
After 10.
Unknown. So it is unknown. His question is, what is the T here, for example? Unknown. What is the T here? I don't know. I am just telling you that the 100 happens at 10. The 20 happens at 2. This is all I have given you. I am not providing you any information. Okay. Okay. Okay, everyone. Here comes the challenging bit. You have to find, for example, the velocity, find V, for example, find V when the object starts. How many students agree? Starts to move, okay? First of all, you need to give me this value. Now, what you have to understand is that somebody has been applying force, right? Like this. Let me make sure that our students can see me screen. Okay. So for example, you see, I put a load, I put a load, I put a load, I keep on increasing the load, I keep on increasing the load, I keep on increasing the load, and now it moves, right? So this means that I have to find the friction force that comes out to be 0.4 into 98.1, which is equal to 39.24 Newton. And similarly, the mu kn comes out to be 0.3 into 98.1, which comes out to be 29.43 Newton. So this problem is not straightforward. If I ask you, what is the velocity of the object after 2 seconds? You don't just do mv2 minus mv1. You don't know if the object has even started to move. How do you figure? Probably the object is not even moving right now. So now this is what you will do. You will say that object starts to move only after 39.24 Newton. So this is what you will do. You will play this little game. Go all the way from here, all the way up to 39.24. How many students agree? I will answer the question. Why negative? Yeah, okay, because, okay, we will think about it. Because at the end of the day, when you keep on putting a load, the object offers the resistance, right? So I keep on putting the load, the object doesn't move. The coefficient of the friction force of the object keeps on increasing. Now that it moves, I have broken the barrier of mu Sn. The mu Sn is the maximum barrier. This object right now is not offering me, let's say, any friction force. I put a load of 1 millinewton, it comes back with 1 millinewton. I increase the load to 10 millinewton, let's say. I'm giving you hypothetical example, it comes back with a 10 millinewton. But at 11 millinewton, if it moves, this means that 11 millinewton is the barrier. That's it. That's mu Sn of the object. So I keep on putting the load, the object, the friction has to be negative force, right? The positive y-axis values are positive. So I suppose this is the answer to your question. You said y below the axis because it's negative. So 39.24 will correspond to 39.24 will correspond to, well, it will correspond to, give me the time, 3.924. Agreed or not? Are you following me? 100 corresponds to 10, 20 in this way. This corresponds to 39.24 Newton. And this happens at what time? 3.924 seconds. Okay. Okay. Then what about the friction mu Kn? Well, that chap exists throughout the motion, right? Now, if the object is moving, look, that's a mu Kn, mu Kn, mu Kn, mu Kn. So you cannot get rid of mu Kn. I hope our students agreed. So tell me, what kind of a line should I make? Anyone? Nobody answered. Straight line, mu Kn. And if you are wondering why in the negative direction, because friction force even mu Kn is in this direction. Okay, what is the value? What is the value? 9, I am asking something else. 29.43. So I will put 29. Let me come up with a very nice color. 29.43. Okay. Now give me the velocity of the object after each nice interval. So I will say, let's say V2 is equal to at 3.924 seconds, the object starts to move. So now that we know it, let's find the velocity, let's say at 10 seconds. Find velocity after 10 seconds or at 10 seconds, whatever. So it will become V2 is equal to mv2 minus V1 is equal to, it will be, so this fellow will be then I will have, let's say, let me put a yellow, no, not yellow. Let's say this light color is good. And I will put a line like this. So this is my area 3, let's suppose. And I will use a yellow color to say this is my area 3. So now I will,
Section, entire section,
nahi,
the triangle.
nahi, this is area 3. This is your, sorry. Oh, acha, got it. Let me answer his question. His question is, this area 3 is the entire section. I think he's right. Thank you. So this is the whole thing. Yeah. Even you have a portion of the triangle. Thank you. Let me. Okay. Okay, now we will finish this by saying mv2 minus v1 is equal to, so play this little game with me. The area of the triangle 1, which is 1/2. Okay, so it will be 39.24 here. So it will be 60.8 into 6.08, then plus the area 2, that is 39.24 into 6.08. Students who don't like this, I will repeat for them. 10 minus 3.924. 1 minute. 3.924. Okay, so then minus the triangle that is below, which is 6.08. Into 29.4 plus, okay, this is v2 minus v1. So v1 is 0. So take the mass and v2 comes out to be 24.4. Yes, please, Hafad.
The force that you wrote, 39.24, it corresponds to 2 seconds in the equation.
No, it corresponds to,
If 39.24 is
no. Look, this is 39.24. It corresponds to 3.924 seconds. I'm telling you, keep it simple. I have told you 100 happens at 10, straight line. Na? 20 happens at 2, 39.24 happens at 3.924.
So can you please explain the black equation again?
what is the 6.01?
What?
What is the 6.01?
Okay, so this is 1/2 base into height. I am trying to find the area of this triangle. What is this? 100 minus 39.24. That gives me height. 1/2 multiplied by height multiplied by base is, so this happens at 10 seconds. This happens at 3.924. So that's why 1/2 base into height gives me this.
Then it happens in 7 seconds.
Why?
Shouldn't we label the 39.24 just above that? Because the black line, it shows the force.
So
The 39.24 should be written up. So it's correspond to 3.924 seconds.
1 minute. I think I need to know his confusion. Okay, I think I understand why. Oh, yeah, okay. Look. I think I understand your point. I understand the point he's making. 1 minute.
At this point, it's 2 seconds.
No, 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 no. एक minute. This is 20. This is 2. Did I make it clear? This is 20. This is 2. This is 39.24 goes all the way here and cuts at 3.924. Okay. Right?
Which one is the first equation? 1.5 times 6.8 times 6.
Oh, acha. Okay. You mean that it cuts the line there, so I should change the 2. That's what you're saying. You mean it cuts this line here, so the 2 should be here. Is this what you're trying to tell?
Yes, that's also logical.
Okay. Now okay. I think I understand his question from here onwards. Okay. Father, I understand. His question is that change the 2 from here to here. Okay. I think I understand what he's saying. He's actually right. You mean 2 here? And
The blue line should be 3.9. This is what I'm
which one? This one?
saying.
Yeah, but then my whole triangle changes, it's too much to change. 1 minute. 3.9. 1 minute. Okay. I think I understand his point and I will try to accommodate it. Okay, hang on. Everything changed now. We are also running short of time. Okay. Like this. So, and then ठीक हो गया. Okay. Is it correct now? Hafad, can you see? Hey,
So
Hafad?
now I'm subtracting that third bracket.
No, 1 minute, I will take your question. Hafad, now it's clear? Sure? Okay. Now I did a control V from the notes actually. Yes, please.
Why are we subtracting that third bracket? 6.08 times.
Yeah, because you need to understand is that I'm adding this area
This area, yeah.
with this area, right? But then I have to subtract anything that is below the y-axis. So what happens is that this plus this minus this. And in case you're wondering what about this area and this area, I don't care because the object hasn't started to even move. So this pretty much vanishes. The top triangle and the bottom triangle, in any case, it adds to 0 and I don't care because the system is not even moving here. So that's why I added this with this and subtracted this. Yeah, you were right. He was right actually. This blue line, 3.924. Yes, 3.924. So that's why I said the system starts to move at, you have to find the V, find, okay, and then we have V2 minus V1. Okay, then we have V2 that comes out to be 24.4. Okay, then the next question is that you have to find the V. And in order to find the V, we are talking about, I suppose, after. So this is my 10 seconds. Now find the V after 15 seconds. So we will have Control C. Find the V after 15 seconds. So I will again play that little game. V3 minus V2 is equal to 1 over 10 into bracket. So add the triangles 4, 5, and 6. And I will get 1 over 2 into 5 into 80 plus 100 minus 5 into 29.43. Okay. Then I will get V2 I already got. So V3 comes out to be 1 over 10 into 1 over 2 into 80 plus 100 minus 5 into 29.4 plus the V2 that we found as 24.4. I really appreciate that you pointed out the mistake. Otherwise, this problem would have been impossible to comprehend. So thank you. So V3 comes out to be no idea. I think 39. I don't know. 6 meters per second. Give me the change in momentum. So I will finish this question and then leave. If some student has class, then please don't hesitate to leave for your classes. Delta G comes out to be M delta V. Let's say from 10 to 15 seconds, I want to see the change in momentum. The answer comes out to be 10 multiplied by 39.6825 minus 24.4. Which is equal to area under the graph. And delta G comes out to be 152.85. Okay. The final part is find the time when the object stops. Find the time when the object stops. So in order to do it, what is your strategy?
V4 equal to 0.
Find the time when object stops. TF, right? So that will be area 1 plus 2 plus 3 plus, did I say 3? No, sorry, I apologize. Plus 4. Keep on adding with me. Plus 5.
Plus 7.
Plus 7. Romans. Plus 7. Minus, did you say minus? Minus 3. Minus 6. How did you figure? Below the y-axis. Okay. Minus?
6 minus 8.
I think so. Good. Minus 8 equal to 0. And now we will do it yourself in your free time. This is 184.832 This is 238.57, I suppose. And 4 is 200. 4 is 200. And 5 is 100. And 7 is 20 into TF minus 15. Sorry, 7 is 20 into TF minus 15. 3 is 178.82. 178.82. And then I will use blue color. 6 is 147.15. And the 8 is 29.43 into TF minus 15. Last time, I think there was some discrepancy, but we will see if our students get this. TF comes out to be 59.7 seconds. Or one of my class students last time said, no, it was 57, whatever. I don't know. Oh, Jesus Christ, this was lengthy, no? So now our class is also over. Really? Did you get it? Good. Thank you. So as one of the students also emphasized, see, this is 2. His point was that this is 2. This is what he was trying to emphasize, I suppose. He was trying to say this is 2. Correct? Huh? This is what you were trying to say, right? Okay. Then it cuts the x-axis at 2. Thank you, everyone. Have a good day. Bye-bye. Okay. So it is tricky, right? Because you keep on applying the force, the object keeps on resisting it. You have to break the barrier of mu s n for the object to actually start the motion. After you have broken that barrier, then at every instant you have to still face the resistance of mu kn. Such a nice example. It gives a very good physical feel of what is happening.
I think meeting is still in progress. You haven't ended.
Yeah, I know. Okay. So on that note, we can finish it. How much?
57.1.
Yeah, that's why every student in the last class also were telling me it's 57. That's why I have given you. Okay, I suppose. Thank you and bye bye. Okay.